We will enter the site of Fukushima Daiichi nuclear power station. On March 11, 2011, when the Tohoku Pacific Ocean earthquake struck, Units 1, 2, and 3 were operating, while Units 4, 5, and 6 were undergoing periodical inspections. That day, a total of approximately 6,400 workers were working at the site, including 750 TEPCO employees and 5,600 corporate company workers. Inside the radiation-controlled area, there were approximately 2,400 people working, all who were able to evacuate within the 40-minute time span between when the earthquake struck and the tsunami arrived. They chose to escape to the hill where the seismic isolated building was located, or into the main control room. July 2007 was when the Niigata-ken Chuetsu-oki earthquake struck Kashiwazaki-Kariwa nuclear power station, an event that introduced the idea of installing seismic isolated emergency centers at each power station site. Obstacles were found during the initial response to the incident. For example, the entrance door of the emergency center was incapable of being opened. The new seismic isolated buildings were designed to withstand larger-scale earthquakes. The construction of the one at Fukushima Daiichi nuclear power station was completed in September 2010, half a year before the accident. During the accident, its function was maintained by emergency power supply provided by a dedicated gas turbine generator, even when all off-site power supply was lost. The building was designed to accommodate approximately 300 people. However, 600 to 700 people gathered at the day of the accident. People rushed even to the corridors and stairs, making it difficult to walk forward. The current number of workers at Fukushima Daiichi nuclear power station is approximately 3,000 per day. 200 TEPCO employees are working inside the seismic isolated building. This area is located at a height of 35 meters above sea level. More than 10 fire engine trucks are deployed as seen on the left side, ready for reactor water injection backup. We also conduct fire training. This is a 4-kilometer long circulation water cooling system, which was installed to recycle the water injected into the reactors to cool them down. After the accumulated water is collected from the basements of the buildings, radioactive materials and salts are removed through this system for re-injection to the reactors. This line will be shortened in the future to improve its reliability. This cylindrical steel tank is the buffer tank for storing the processed water, which has been accumulating in the basements of Units 1 to 4. The water is injected back into the reactors of Units 1 to 3. These facilities are located on the hill at the height of 35 meters above sea level, where there is expected to be little if any impact from tsunamis. An air-cooled chiller is operated during the summertime to cool the water inside the tank and mitigate the temperature increase of the reactor injection water. The pumps on the rear deck of the truck are the reactor injection pumps for Units 1 to 3. The ones in the front are the regular pumps, and the ones at the back are the emergency backup pumps. Of the 3 regular pumps and 3 backup pumps, 2 regular pumps are operating at the usual times. A pump capacity is 20 cubic meters per hour, sufficient enough to remove decay heat which generates from the 3 reactors. The power source for the regular pumps is the on-site power, and that of the backup pumps is the power from the diesel generator seen at the back. These facilities are seismically reinforced. Furthermore, 3 more reactor injection pumps, which were installed just after the accident, are located in areas 10 meters above sea level. The water source of these pumps is the buffer tank mentioned before, whereas other freshwater supply lines are also installed for backups, which comes from the filtered water tanks. This is the building where 750 employees were working before the accident. You can see that the building sustained serious damage, including to its interior, especially the windows destroyed by the hydrogen explosion at Unit 1. The building is now left as it was just after the accident, as its condition is so bad that it cannot be used as a workplace. The construction area over the grove is the area for the temporary facility to store dry casks. We are planning to move the fuel from the spent fuel pool starting from Unit 4 to the common spent fuel pool, while moving the fuels there to the dry casks and storing them here. This is the multinuclide removal facility. It keeps the radioactive material density of the already processed accumulated water at an even lower level. The existing water treatment system mainly removes cesium. However, this facility realized the removal of up to 62 kinds of nuclides. It is starting operation after its performance is confirmed through the currently ongoing system tests. We are progressively installing tanks at the site to store the accumulated water, mainly as desalinated or reverse osmosis concentrated water. The accumulated water contains rain or underground water which is continuously flowing into the reactors. 240,000 tons of water was stored by the end of November. The capacity of the cylindrical tanks is approximately 1,000 tons. Horizontally long blue tanks have a capacity of approximately 100 tons. Dams are built around the tanks to prevent water from spreading out should it leak from the tanks. Drainage paths are turned into closed conduits should water from the tanks or the water lines leak out. Steel tanks cannot be installed around the area under the transmission lines where cranes are unable to approach. In those areas, there are plans to install underground reservoirs instead of steel tanks to store processed water for effective utilization of the site. The total capacity is designed to be approximately 58,000 tons. The underground reservoirs will be sealed by triply covered sheets with leakage detectors between the sheets. Water leakage will be monitored by water level indicators. Temporary electricity lines have been used to supply power to the station after the earthquake, since off-site power of all units was lost due to the collapse of a power line tower and the damage sustained by circuit breakers at the on-site switching station. This is the 66 kilovolt south side switching station, a newly built electricity line for regular use. It has been operating since April 2012. The electricity is delivered to such as the water treatment system and the alternative cooling systems at the spent fuel pools of Units 3 and 4. For emergency use, one air-cooled diesel generator is currently connected to this line. The second one is also connected and is under inspection in preparation for the start of operations. The white tent-like building is the building for the reverse osmosis membrane and the evaporative concentration facilities. These are the facilities to desalinate the accumulated water after its oil and radioactive materials have been removed. This building is the control room for the contaminated water treatment system to conduct integrated monitoring and operations for each facility that is involved in the decontamination of accumulated water. The monitoring and operations are conducted all day and night, with 10 operators working in shifts on 24-hour schedules. From this perspective, one has a bird's-eye view of Units 1 to 4 reactor buildings. Its height is also 35 meters above sea level. The building covered with a white cover is the Unit 1 reactor building. As the upper part was damaged due to the hydrogen explosion, the whole building was completely covered to prevent radioactive material from scattering by October 2011. The building at the front of it, with pale blue and white patterns, is the Unit 2 reactor building. Unit 2 remains as it was before the accident, as it did not suffer a hydrogen explosion. Unit 3 is in front of Unit 2. The upper part of the Unit 3 reactor building was also damaged due to the hydrogen explosion, leaving the collapsed building walls, pillars, roof truss, steel beam and concrete parts piled up on the top floor. A gantry to support heavy machinery is constructed at the side of the building to remove the debris. The building at the front is Unit 4. The top floor looks like a rooftop, since all the debris on the top 5th floor have been removed. In preparation to take out the fuels from the spent fuel pools of Units 3 and 4, debris removal remains ongoing. The work for Unit 4 was started earlier than Unit 3, for its surrounding radiation dose is lower than Unit 3. Meanwhile, for Unit 3, whose top floor radiation dose is too high for men to work inside, debris removal is conducted using remote-controlled cranes. We have descended to an area 10 meters above sea level from a height of 35 meters. The building on the left is the common pool building, where the spent fuel generated in each unit is stored. The damaged equipment is being restored. Before we remove the fuels from the Unit 4 spent fuel pool, the fuels currently stored in the common pool will be put out into dry casks and moved to a temporary storage area. At the time of the accident, the 2 emergency diesel generators installed here failed to function since the switchboards connected to them were flooded by the tsunami. This is the high-temperature incinerator building, where the second cesium absorption apparatus is stored. The spent vessels, which are the cartridges for the absorption apparatus, are temporarily stored in the building next to it. Now you can see the Unit 4 reactor building. At Unit 4, which was under periodical inspection at the time of the accident, all the fuels in the reactor had been moved to the spent fuel pool for the reactor shroud replacement. On July 18th and 19th, 2 out of the 204 unused fuels in the Unit 4 spent fuel pool were taken out for a soundness inspection and moved to the common pool. No major scratches or corrosion was found on the fuel assembly and the fuel rods inside. We have almost completed removing the debris on the top floor and the rebars and concrete debris which were hanging down from the walls. The cover for fuel removal will be installed to take out the fuels from the spent fuel pool. Preparations are underway to start taking out the fuels by the end of 2013. The place you are now looking at is the 5th floor of the Unit 4 reactor building. Considering that there are about 1,500 fuel assemblies inside the spent fuel pool, and the damage of the Unit 4 reactor building is more widespread compared to Units 1 and 3, soundness inspections for the building are performed every 3 months. Specifically, the following 3 points are inspected. First, the building tilt is examined by measuring the outer wall deformation and the water levels of the pool and the well. Next, the building is visually inspected for cracks. Finally, its concrete strength is evaluated. The results of the inspections so far indicate no problems with the building's soundness. Also, it has been confirmed that there is no problem with its seismic safety as a result of a conservative calculation on its current seismic capacity, assuming an earthquake equivalent to the Tohoku Pacific Ocean earthquake. Furthermore, by reinforcing the bottom of the spent fuel pool, the seismic safety margin in the vertical direction has been further improved by 20% or more. This is the incineration workshop building, where the cesium absorption apparatus is stored. The apparatus removes cesium by utilizing a special material called zeolite, which absorbs radioactive materials. This is the process main building where the decontamination facility is stored. The accumulated water transferred from the turbine building is stored in the process main building and the high-temperature incinerator building and persists through the treatment system newly installed on the upper floors of the buildings. As you can see, the vegetation conditions of this slope differ across the boundary line, which is located at a height about 5 meters from the road surface. This shows that the tsunami struck the slope up to its height. The tsunami came directly from the coastline, as this area was not protected by the seawall. The pile of black net bags filled with rocks is a temporary seawall that was created in June 2011. It was a measure against the tsunami that would follow a magnitude 8 scale aftershock, which several experts pointed out will occur in the offshore side of the earthquake center of the Tohoku Pacific Ocean earthquake. 4,700 net bags of rocks were piled up to a height of approximately 4 meters along the coastline. The seawall will prevent the tsunami from finding its way to the land, where the buildings housing the water treatment system are located. The reactor building and the turbine building are built 10 meters above sea level. The assumed tsunami height was originally 6.1 meters. However, the actual tsunami was approximately 15 meters high, which flooded into the building through the equipment hatch and the emergency diesel generator air supply louver. The power panels and the diesel generators installed on the first and basement floors were flooded, rendering them inoperable. Within this area, the radiation dose is the highest around Unit 3. The green paint on the building surface is the anti-scattering agent sprayed on the walls to maximize the prevention of radioactive materials which were floating in the air after the hydrogen explosion. The trucks and the cranes in the surrounding area were turned over by the tsunami and got stuck in the reversing valve pit. Water shielding walls are planned to be built at the Units 1 to 4 water intake area for the purpose of preventing pollution spreading to the ocean in the case of groundwater contamination. The ship is drilling the bedrock in the area where the steel pipe sheet piles are going to be placed. In the outside of the port in the south side, a foundation mound made of wave-dissipating blocks will be built to support the shielding walls. About 600 steel pipe sheet piles with a diameter of 1 meter and a length of 20 to 30 meters will be installed, which will extend to a total length of approximately 800 meters. The ship on the right is a megafloat provided by Shizuoka Prefecture. The megafloat was used for temporary storage of seawater transferred from Units 5 and 6. At the time of the earthquake, 9 dry casks storing a total of approximately 400 spent fuels were placed in the dry cask storage. Although the building itself and the facilities inside were damaged by the tsunami, there was no major damage to the dry casks. The dry casks are placed sideways and have a double cover structure. Due to the tsunami, the building was flooded with seawater to its ceiling and the casks were completely submerged in water. The outer cover of the casks, which seems to have been exposed to seawater, was cleaned and dried. The radiation dose and the temperature are measured once a week. For the thermometer and the pressure gauge, which was originally installed inside the double-covered structure, cannot be used for checking the soundness of the casks. As the current radiation dose and temperature are the same as those before the earthquake, the casks are considered to be fulfilling their intended function. The casks are planned to be transported to the common pool for inspection. The tank on the right is the suppression pool surge tank, where water generated during periodical inspections was stored temporarily before the earthquake. The lower part of the tank was deformed due to the tsunami. 2 heavy oil tanks lay next to it. Though they were originally placed side by side, the tsunami caused one of them to be moved towards the other. Since the breakwater was destroyed by the tsunami, tetrapods have been installed as substitutes as seen on the back. On the left, you can see the Units 5 and 6 turbine buildings. Since this area is 13 meters above sea level, the tsunami damages were not as severe as Units 1 to 4. However, the seawater pump area is 4 meters above sea level, of which the damage degree is similar to Units 1 to 4. The radiation doses around Units 5 and 6 are substantially lower than those around Units 1 to 4. This emergency room was opened in July 2011 for the purpose of providing primary care in the case that the on-site workers need emergency medical care. ER doctors work in shifts around the clock. The emergency room was located here considering that the radiation dose in the surrounding area is sufficiently low and would allow for the staff to stay at all times. The building on the right is where the emergency diesel generator 6B is located. This generator was the only power supply in the power station which survived the tsunami. There was no direct damage to the building, for it was installed at 13 meters above sea level. The tsunami seemed to have reached just below the air supply louver. Since the generator only requires air, not seawater for cooling, it continued operations without being affected by the tsunami. The generator transferred power not only to Unit 6 but also to Unit 5, which prevented the reactor core from being damaged at these units. Units 5 and 6 were receiving external power through two lines of the 66 kilovolt Yonomori line. A power line tower fell over due to a collapse of a large embankment in the surrounding area after the earthquake, which led to a loss of off-site power supply. Now the two lines of the 500 kilovolt Futaba line originally used for power transmission are being used for providing power to the two units. The power is supplied to these lines from Shin Fukushima substation located 10 kilometers from the power station. TEPCO will maintain its efforts towards the stabilization of Fukushima Daiichi nuclear power station by harnessing expert wisdom from around the world.